Welcome to The Explainer. Today, we're taking a look at a pretty fascinating journey. We're going to trace the exact life cycle of how connected tech actually scales. Think about it. How exactly does an idea go from a messy weekend experiment on a hobbyist's desk all the way to a polished, globally available app downloaded by thousands? It's a wild ride, and honestly, understanding it gives you a whole new appreciation for the digital ecosystem we use every single day. Let's dive in. So, here's our roadmap for today. First up, DIY prototyping with the ESP8266. Then, we'll see that tech applied to IoT in smart agriculture. After that, we'll tackle the enterprise scaling challenge. And finally, number 4, we'll look at commercial apps, specifically one called SplitBlink. Basically, we're moving from micro hardware tutorials to macro commercial software. From a blinking LED to a global app, building connected tech has never been easier or more complex. Let's unpack that for a second. The barrier to entry for building smart devices has literally plummeted over the last decade. But the ecosystem connecting raw circuitry on a plastic breadboard to a slick one-click download on the App Store, that remains incredibly intricate and deeply layered. Which brings us to part 1, DIY prototyping with the ESP8266, the basics. Let's start right at the foundation. We're looking at a really brilliant Instructables guide by creator Suchinder Radis. Now, we can distill their highly technical 14-step hardware process into 4 core phases. First, you set up a Blink 2.0 account and a device template. Next, you create your data streams for your inputs and outputs. Third, you hook up your physical hardware, in this case a Node MCU ESP8266 board, right to your computer's Arduino IDE. And finally, you upload your C++ code and wire up the physical red and green LEDs. It's awesome because this beautifully illustrates just how accessible it is today to connect a physical light bulb on your desk to a digital control dashboard hosted out in the cloud. But the absolutely crucial point here is understanding how that connection actually happens. Data streams. These act as the channels for any time-stamped data flowing in and out from the device to the cloud. By the way, if you've used older hardware, you probably know these as virtual pins. Think of these data streams as the invisible digital threads that make the Internet of Things possible. They're what allow the cloud to talk directly to the hardware and the hardware to talk right back. All right, moving on to section 2, IoT in smart agriculture, turning theory into practice. So now that we know how to turn on a simple LED, what happens when we apply that exact same technology stack to a massive real-world industrial problem? Well, to see how this scales, we're turning to an academic paper by researchers J. Lidwina Jennifer and H.R. Yalakia. If you look at this block diagram from their research, you can see the architecture of their smart agriculture system. Right at the center, acting as the main brain, is an Arduino Uno working alongside that very same ESP8266 Wi-Fi module we just talked about. But instead of just blinking an LED, this central hub is processing complex data from a whole array of environmental sensors. We're talking moisture, motion, temperature, smoke, and it's sending it all straight to a mobile device. What's really cool here is seeing that theory become reality. Over on the left, you can see their physical prototype. They've got sensors wired up and plunged literally right into a cup of soil to measure volumetric water content. And on the right, that's their custom Blink mobile dashboard interface. It's the exact same platform used in that simple LED tutorial, but here it's been totally transformed into a working, real-world agricultural and warehouse monitor. Let's break down exactly what this smart system is doing, because it works completely autonomously. The DH11 sensor measures soil moisture, right? If it's too dry, boom, it triggers a physical water pump to irrigate the field. The LM35 sensor monitors temperature. So if a grain warehouse gets too hot and risks crop damage, it automatically fires up a cooling fan. A PIR sensor detects infrared motion to trigger an ultrasonic repeller against intruders, and the MQ2 sensor detects smoke, instantly firing off a mobile cloud alert. So you have this closed-loop system reading physical conditions and instantly triggering precise mechanical responses with absolutely zero human intervention. That brings us to section 3, the enterprise scaling challenge. Let's look at the friction in the market. Prototyping a smart agriculture system is an incredible achievement. But what happens when you want to take that brilliant prototype and turn it into a commercial product you can actually sell to hundreds of farms? Well, the friction of scaling is very, very real. On the Blink community forum, a user named Sanju6484 writes, "I need help for Blink Enterprise regarding development app for our college project prototype, but there is no response from Blink forum. I think this perfectly captures a really universal struggle. You have all these students, makers, and innovators who successfully build an ESP32 prototype, but then they just hit a brick wall. Navigating that daunting leap from a working internal prototype to a public-facing, white-labeled enterprise product, it's incredibly stressful and complex. Fortunately, a community moderator named Pete Knight stepped in to clarify how this ecosystem actually works at the business level. Basically, the Pro tier is strictly designed as a proof of concept. It's got accessible pricing meant for makers to test out their ideas. But the Enterprise tier, that is a whole different ballgame. It requires building a custom white label app, meaning your own branding, plus dedicated App Store publishing and some heavy back-end customization. Pete Knight noted that historically, this level of enterprise support started around $450 a month. That is a stark contrast from those cheap, accessible testing phases to the heavy financial and developmental realities of launching a dedicated commercial app. Finally, Section 4, Commercial Apps, looking at SplitBlink and the final polish. Now we arrive at the absolute top layer of the connected tech ecosystem, developed by a company called Habrian Limited. SplitBlink represents a fully realized, polished piece of consumer software. All the wiring, the server costs, the enterprise publishing, it is all hidden behind a super clean user interface. SplitBlink solves a very specific, everyday human problem, splitting expenses fairly. Whether it's students sharing rent and internet, housemates managing groceries, or just friends tracking expenses on road trips and pub nights, it solves the awkwardness of money chats with customized tracking. I mean, think about the contrast here. We started this explainer by literally wiring a physical light bulb on a breadboard. Now, at the commercial level, the end user doesn't see a single wire or a single line of code. They just download a sleek solution to split a dinner bill, completely abstracted from all that underlying tech. But as you might guess, that polish comes with some pretty strict requirements. Notice that 13.0 on the screen? That represents the minimum Apple iOS version required to even run this app, and the app itself is an 85.5 megabyte package. Because at this commercial layer of technology, you aren't just making sure your C++ code works on a little microcontroller on your desk, you have to meet the rigorous deployment specifications, privacy policies, and compatibility requirements of massive global platforms like Apple. And there you have it, the full life cycle. From setting up a basic data stream for a tiny green LED, to deploying autonomous water pumps in agricultural fields, navigating the intense friction of enterprise scaling, and finally delivering a seamless, polished application right into a consumer's pocket. The connected tech ecosystem is vast, deeply layered, and honestly incredibly powerful. The tools are out there, and they're way more accessible than ever before. So the only question left for you is, what will you build next? Thank you so much for joining me on this explainer. Keep learning and keep building.